G'day everyone. I recently released my first R package, which is called metameta, which is a suite of functions which help you analyze published meta-analyses. And the first set of functions that come with the package look at ways that you can actually calculate the statistical power of studies that are included in meta-analyses. And this is really easy because all you have to do is extract the data which is commonly reported in most meta-analysis forest plots, which is the effect size and a measure of variance, typically standard error, but sometimes confidence intervals. So let's get started. First thing we're going to do is to install the package from GitHub, which is where the package is hosted, and we are going to load the package as well. And as part of the package, I included 3 example data sets just to show you how things work. So we're going to load one of these data sets just to have a look at the structure, how these things look. So here we have a meta-analysis which included 12 studies, and the effect size, which is in the column YI, and also measures of a lower bound and an upper bound, which we're going to use to calculate power along with the effect sizes. So this is an example, and when you're actually running this function, it's important that your data is structured this way. There needs to be at least these 3 columns for this particular function: effect size, lower bound, and upper bound. Let's go back to the actual function, and it includes 3 arguments. The first one is where you enter in the data set, and the second one is the observed effect size. So the observed effect size, or the summary effect size from the meta-analysis. So if we actually have a look at the meta-analysis, we can see these are the exact values which I have in the data set, but we also have this combined, or this summary effect size estimate of 0.08. And that is what we are entering for our function as our observed effect size. So let's run this. And let's take a look at basically what this function is. It returns a list with 2 things, with 2 bits of information. And let's take a closer look at what it returns. Okay, the first thing is the actual data file. So this particular data file, it shows us the studies again, the effect sizes, and the lower and upper bound. It also shows you the standard error, which was calculated based on the lower and the upper bound. And the rest of the columns give you your statistical power for a range of true effect sizes. Now, in practice, a true effect size can be hard to actually think about, or it can be hard to determine for a lot of subject areas. So what can be useful is actually determining a range of effect sizes, and you can actually see what sort of effect sizes can you actually reliably detect based on a particular study design. So for this particular function, what it returns is the actual assuming that the summary effect size estimate is the true effect size, which may be a little bit conservative, considering that published meta-analyses often inflate effect sizes. But we also have a range of effect sizes going from 0.1 to 1. So you can actually see, assuming for a range of true effect sizes, what is the statistical power of each study that goes into a meta-analysis. Okay, so the other thing that we can actually get out from here is the medians. So this is exactly the same information, but it just takes the median for all those columns that we had previously for the observed power, and also for the observed effect size, and also for a range of possible effect sizes here. Okay, so we're just going to run that as before. Okay, so that is one of the main functions that is in metameta. The other thing is as well, you can actually combine a set of meta-analyses. These can either be meta-analyses which are published within the same article, or meta-analyses published in different articles which cover the same topic. And you can visualize the statistical power for a range of true effect sizes across different meta-analyses. And this is super cool, these firepower plots, which is what I've called them. So we're going to be doing the same analysis on the 3 example data sets data sets which are part of the package. We're going to run the analyses, and we're going to put the results of the analyses into a list. Now, all this code is in the GitHub README, so there's no need to actually look at what I'm typing. You can go straight to the GitHub README for the package and get the exact same code and run this for yourself. So we're going to run these three things, and based on what we created, we're going to create a list called list_power, and from this we're going to enter this list in the firepower function to create the plot. It only has one argument, and all you have to do is put in this list that you've created. Let's have a look, and let's take a look at our plot. There we go. So we have our three meta-analyses. Now keep in mind, this is the median statistical power for a range of possible true effect sizes for these three meta-analyses. So we can see there's one column here, which is standing off to the side, which shows you the power for the observed effect size. That is the reported summary effect size estimate, assuming that's a true effect size, which probably isn't true. Then you also have a range of effect sizes from from 0.1 all the way to 1. So we can see here from the Keach study that only when you get to around 0.6, 0.7 do you actually reach 80% statistical power, which is one guideline which is commonly used. So for these particular set of studies, essentially you can only reliably detect effect sizes which are this large. So if you're satisfied that that is the true effect for your particular research field, and for some research fields that's true, this is fantastic. Those studies are appropriately powered. But what this does mean is that if your true effect size is lower than this, you cannot reliably detect or reject these true effect sizes. And looking at these meta-analyses here, the situation is a little bit worse in that they can only reliably detect quite large effect sizes. So those are the first two functions or two families of functions that are included in metameta, and I hope to include more stuff in the future. So let me know what you think and send us your feedback.